Good morning, everyone. This is Sibanjum from St. Mary's School, Nagina. I hope you all are good. This is the lecture number 10 of your computer applications with BlueJ of class 10th. So today in this video, we are going to deal with unit number 6, that is your mathematical library methods. So firstly, let us see what are the topics we are going to discuss today. Firstly, we will see what are the methods of your math class. Then we are going to see some of your trigonometric functions. Then afterwards, we will be solving some sample programs. And then afterwards, some of the exercise portion we are going to solve. And at the end of this video, you will be getting some sample questions and you have to give me the solutions for the same. Now starting with the first one, that is your methods of math class. Basically what your Java developers does, that they combine all the mathematical function into a single class, and that class is basically what your maths class. So whenever you are going to write down any function of your math class, you have to write down math dot followed by your function. Okay, now see at the right hand side you are having a particular syntax. Now let us explain this thing. See, the first thing that you are going to get over here is your return data type. Yes, firstly you will be writing your return data type, then afterwards some variable that is perfectly user defined, and then afterwards you will be getting what? A function name with arguments. Those function name we are going to discuss now after some minutes. Yes, so see over here the concept is this, that this function always returns one value. Okay, every mathematical function returns a value, and you can take this value depending upon your choice. Either you can take this value and store it in a variable, or you directly use this value and print it on the screen. So you are having two methods. If you are going to follow the first method, or you can see if you are going to save the variable value of those mathematical function, then you will be using this syntax. And if you want your value to be directly printed on the screen, then you will be using this system out println, and within those brackets you will be writing this function name with argument complete thing. Okay, now let us start with the first mathematical function, that is your math.min. As the name suggests, it is going to give you the minimum value. Now see, on the left hand side we are having a return data type. Return data type means the function is returning you a value. Now what kind of value it is going to return to you comes under your return data type. So over here in maths.min, it depends on the type of argument. Yes, the type of argument will define that what kind of value you are going to receive from the function. And over here the number of arguments are 2. Always they are 2. They cannot be 1, they cannot be 3. Always you have to give the arguments in 2 numbers. Okay, now see the first example. We are having math.min 45.25 and 89.2. So among those two you have to find out the minimum value. Obviously you will be getting what? 45.25. The thing to notice over here is that over here you are giving double type of numbers. Yes, and the result you are getting as double. So that is what this line means. It depends on the type of argument. See, in the second example we are having math.min 45 as well as minus 20. So the minimum number is what? Minus 20, and it is an integer. Yes, now see again what kind of questions you are going to get regarding this function is, either you need to find out the outputs, or you might be getting a program in which you were asked to take 3 or 4 variables, and you have to find out the minimum value among those variables using this function, and you know that only you can use the number of argument as 2. So at a time only 2 variables you can check, so you have to apply the appropriate formula or appropriate concept for the same. Now let us take an example. Consider this case. You have to find out the minimum value among 3 variables. Okay, now let us take A, B, C as your variables. They are holding some value. Afterwards we will see what kind of value they are going to hold. Okay, now for now you can choose any two variable. Either you choose A and B, or you choose B and C, or you choose A and C. It depends on you. For now let us choose this A and B. Okay, now we are going to apply maths.min function over here, and we are going to store the value in a variable, let us say d. Yes, now we are having what? C we are having and d. So now we are going to apply the function on both, and we will be storing the result in your e. Now at the very end, this e will be holding the minimum value among these three variables. Now consider, let us take an example. Let us assume that the value of a is 1, the value of b is 2, the value of c is 5. Okay, now if we apply the math.min function between those two, then you will be getting what? 1, because 1 is minimum. Yes, again we have to apply math.min function on c and d. Then you will be getting what? You will be getting 1 as an answer. So anyhow, you will be getting the least number over here, and that is what we wanted to do over here. Now see again, the second mathematical function is your math.max. Now see, it is very much similar to your first one. Over here also the return data type depends on the the type of arguments, and the number of arguments are what? They are 2, as we have seen in the first example or in first function. Now see, over here the example math.max 45.25 and 89.2, you have to find out the maximum value, so obviously you will be getting what? 89.2. And in the second one, now you cut down min over from there and write down max. So if you find out math.max among 45 and minus 20, then you will be getting what? 45. So over here in the first example you are getting a double value, and in the second example you are getting what? An integer value. Yes, and the same kind of question you are going to encounter with this function also, that you will be asked to find out the maximum value among 3 or 4 variables, and you will be following the same concept as we have followed in the first mathematical function. Okay, now see the third one, math.pow. Now regarding your third mathematical function, that is your math.pow, basically it is your compressed version of power. Yes, so over here we are going to calculate the power function. Now see over here, let us assume we have to find out a to the power b. We have to find out the value of a to the power b. Then let us write down the mathematical function. We are going to write down math.pow, and in brackets you will be having two arguments. Yes, and they are separated by this comma. So the first argument is basically what? Your base value. Always the first argument that you have to write is your base value, and the second one you will be writing is what? Your power. So it means a to the power b we are going to calculate, and at the very end you will be applying a semicolon with the same. Okay, now see over here are some examples. Double val 1 math.pow 2 comma 3. So you are going to calculate what? 2 to the power 3. Obviously you will be getting what? You will be getting 8. And now over here at the left hand side, please see the return data type is double. So you are going to get 8.0 as an answer, because your return data type is double over here. Now see the second example, you are having what? 2.0 to the power 4.0. Again you are going to get 16.0 with this example. Now see, if in question or if in exam this question came and you have written only this 8, then your marks will be reduced because of this point 0. So please mention or please make a note that this point 0 you have to write down over here. The number of arguments are always true for this function also. Now moving forward with your fourth mathematical function, that is your math.square root. Yes, over here we are going to calculate your square root. See, the return data type is double. The number of arguments are 1. Either you use a single value, or you use a single variable, or you can use an expression, but the number of arguments should be 1 in case. Now over here see, either you can use some value, likewise you can say under root 14 you can calculate, or you can use this under root a where a is a variable, or you can use any expression, likewise a plus b plus c, but the number of arguments should always be 1 in this case. Now see the example, we are having what? Math.square root 7.29. So if you calculate under root 7.29, then you will be getting what? 2.7. Again over here, see, in the second example, you are going to calculate under root 400. Yes, we are having very simple answer over here. 20 you are going to get, but the return data type is double, so you are going to get 20.0. Yes. Now moving forward, we are having the fifth mathematical function as your math.cube root. Now over here it is very much similar to your math.square root. We are going to calculate this function over here. The return data type is always double. Number of arguments are always 1. Either you can use a variable or a value or an expression as we have seen in your square root function. Now over here, please see an example. For math.cube root, 27, if you find out the cube root of this 27, you will be getting 3, and the return data type is double, so you will be getting 3.0. Now see the second one, you are having 29.791 and you will be getting 3.1 as an answer because it is the cube root of 29.791. So over here you have already seen that you just have to apply the function, and within those brackets you have to give the values. Yes. Now moving forward with your sixth mathematical function, that is your math.log. Basically this function is going to calculate your logarithmic value, but the base is what? The base is e. Every time it is going to give you the logarithmic value with the base e, and over here also the return data type is double. The number of argument is also 1. Now see the example. In the first example, if you calculate math.log 6.25, then it is going to give you an appropriate answer, and the same goes with your second example. Okay. Now see the next one. We are having math.apps. Basically this function is going to give you an abstract value. The return data type always depends on the type of argument, which type of argument you are using. Either you are using an integer or a long or a double, the same kind of value you are going to get in return. Number of argument is always 1. So basically see this, what this function does is, if you are having a negative value, then this value will be changed to your positive one, and in case you are having a positive value, then there will be no change in the value. Okay, the number is not truncated, it is not being rounded off, just it is going to give you the opposite sign in case your number is a negative number, and for the positive number you won't be getting any change with it. See the example in the first one, math.apps minus 12 you are having. Yes, it is an integer argument, so you are going to get the value as an integer. So 12 you are going to get in return. Now see the second example, you are having 15.69. It is a positive number as well as a double kind of number, so you will be getting the same as a result. Now moving forward, math.exp. This function is going to give you the exponential value. Likewise, you are calculating in your mathematics. In your mathematics, you are calculating this function, yes, e to the power x, and over here by our argument we mean we are going to give, or we are going to apply the value of x over here. Yes, the return data type is always double. The number of arguments are always 1. A single argument we are going to use over here also. See the first example. Math.exp 6.25. So in this we are going to calculate what? E to the power 6.25, and this is the result that we are going to get. Now again see the second example. If you calculate e to the power 7, then 1096.6332 you are going to get as a result. Okay, so now moving forward with your some more mathematical function. See over here we are having math.rint, basically rent function we are going to get over here. The return data type of this function is double. Number of argument is always 1. Now let us compare basically this function to your math.round function. Yes, so these are the very popular mathematical function, and basically in your exam you are going to get the difference. Yes, you are going to write down the difference between those two functions. So the difference is what? First difference is this one, the return data type is double in math.rent, and in math.round the return data type is either an integer or a long one. And the second example is what? See, you are having a value. Let us assume you are having 8.5 as an value. Yes, so if you apply this function math.rent over here, then it is going to give you what? 8.0. Why? Because this rent function is going to give you the nearest in even integer number. Okay, and if you check the same number with your math.round, then it is going to give you the round of value and you will be getting 9 as an answer. Okay, you will be getting 9 as an answer. Now see, this condition is only applied when you are having this 0.5 over here. Okay, getting the point? If you are having this 0.5, then only this condition is being applied. Yes, and again let us assume one more example. See, if you are having this 8.4 with you, then this is less than 0.5. Yes, so it is again going to give you 8.0 if you apply this rent function, and for your round function also it is going to give you 8, only 8, because it returns you an integer or long value, and this 8.0 because your rent function returns you a double value with the same. Okay, and if you are having this 8.5, then only this zero point 0.5 we are getting now, so your rent function is going to give you 8.0 over here, and your math.round is going to give you what? It is going to give you 9 with the same number. Now see the example. The first example of math.rent, it is 8.5 and it is getting 8.0. We have already discussed it. Now see the second one, you are having minus 9.5. Yes, minus 9.5 it is. It is going to give you the nearest integer value. Nearest, sorry, your even value. So minus 9 is not an integer, but minus 10.0 is an integer one, and you are going to get the same as an answer. But please remember, again I am repeating the thing, that this condition is only valid if you are getting this 0.5 or more at your right hand side, means after the decimal. If you are getting the number 0 0.5 or more than 0 0.5, then only this condition will be applied. And if this one is your minus 9.2, then you will be getting what? Minus 9.0 as an answer. Okay, now see the examples of math.round. The first example is, you have to round out the value of 10.5. It is very simple. You are going to get 11 over here. And for the math.round minus 10.5, you are going to get what? 10, because it is going to give you the higher value. Okay, it is rounding off your value and going to give you the higher value, and hence your minus 10.5 will give you minus 10, because minus 11 is anyhow smaller than your minus 10.5. That is the reason for the same. Okay, now moving forward with those two mathematical functions, these two functions are also very much important, your math.ceil as well as your math.floor value. Okay, in the exam you might have asked to find out the difference between math.ceil and math.floor, or you might have asked to give the output for the same. Now see, the return data type is double in both the cases. The number of arguments are also one in both the cases. Now see the example. Basically, firstly understood the concept that your math.ceil value is going to give you the higher value. Yes, and your math.floor value is going to give you the lower value. Okay, now see the example number 1 of math.ceil. You cut down this log and write down ceil over here. Yes, again in the second example also you cut down this log and write down ceil over here also. So see, in the first example you are having 8.5 and you have to find out the ceil value. So again it is rounding off your number and it will be giving you 9.0, because 9 is more than your 8.5. Now see, if you are having the negative number, then for minus 8.5 you will be getting what? Minus 8.0. You will be getting what? Minus 8.0, because your minus 9 is anyhow smaller than your 8.5, and that is why you are going to get what? Minus 8.0 over here. Now see, in the maths.floor, what you are going to get, if you are going to calculate this value of 18.912. See over here, after the decimal you are having the number more than zero point 0.5, but again you will be getting this 18.0 because this is going to give you the floor value. It means the lowest integer it is going to give you, the lower nearest integer. Yes, but if we encounter it for the negative value, then see minus 18.912 if we are going to get, then you will be getting what? Minus 19.0, because minus 19.0 is smaller than your minus 18.912 with the same. So basically these four functions are very much important. You please practice these functions on your own. Now moving forward with some of your trigonometric functions over here, we are also having. Now there is a slight change in the syntax. See over here on the right hand side, you have to give the values in radian. In an argument, you have to give the value in radian, not in degrees. If you are having the value in degrees, then firstly you have to convert them into the radian appropriately. Then you have to give the values to the as an argument. Now see, the first trigonometric function is your math.sine. As the name suggests, it is going to give you the appropriate sine value. Return data type is double, number of argument also 1. Now see the example, it is going to give you what? The sine value of 8.5, that is your 8.0. In the second example, okay, the second example is same, you just see the first example. Now see the second trigonometric function, that is your math.cos. Again it is going to give you the double value. Number of arguments is 1. See the example. The cos value of 8.5 is what? 9. Again leave the second example. It is the same. Now moving forward with the third one, it is going to give you the appropriate tangent value. So basically for this function also our return data type is double, number of arguments are also 1, and over here like this we are going to use this function for the same. Now see, one thing to remember over here is that you have to apply the values in radian. Okay, you don't have to give the values in degree. Firstly convert them into the radian, then afterwards you apply the value for the same. Okay, now see one more function we are having, one more important function, that is your math.random. It is a very unique function because in every other function you have seen what you are giving some arguments, but in this function you are not going to give any argument over here. The return data type is always double. Now see the first example, you just have to write down what? You just have to write down this math.random, and it is going to give you a random number, a double random number between 0 and 1. Okay, so this function is basically designed to give you a mathematical double random number between your 0 as well as 1, and we can modify this function to find out the random number between any two numbers. So again we are going to see how we are going to modify this function. See over here these two values. Yes, now see the first one, we are going to get the random number between 1 to n. You are having any number n and you are going to find out any random number between 1 to n. Now what you have to do, you just have to multiply this math.random with n, and afterwards you have to add it by 1. Then what you are going to get, you are going to get a double random number between 1 to n. But if in case you want a random number and it should be of an integer data type, then you have to explicitly typecast this function over here. Yes, remember we have studied implicit type conversion as well as your explicit type conversion. So over here we are doing your explicit type conversion. So you are going to convert this overall function into your integer, and then the r1 will be going to store an integer random number between your 1 and n. Okay, now see the second function. In the second function, what we are going to do is you have to find out the random number between m and n, where your m is less than n. It should always be your less than n. So what we are going to do, math.random multiplied by the difference between your n minus m. N minus m, because n is larger and m is always smaller. Over here in the first one we are not finding out the difference because your starting point was 1, but over here your starting point is m. That is why we are going to calculate the difference between your n and m, and at the last you are going to add this m. Okay, now you are going to get the double random number between m and n, and if in case you want an integer random number, then you have to explicitly typecast it. Yes, now this r2 will be going to store what? This R2 will be storing your integer random number between m as well as your n. Okay. Now let us see some sample programs with the same. The solution of those sample programs are already present in your book. So please try these programs on your own, but understand the concept over here. See, the first sample program that is present in your book is: write a program in Java to input three numbers and display the greatest number. You have to use this math.max. Remember when we were learning about this mathematical function, then over there also I told you about this kind of question. Yes, so firstly what you have to do, you have to input three numbers. Three numbers you have to input, either you take ABC or you take M and O, depends on you, and you have to use any of the input function. Either you use this scanner class or you use input stream reader, depends on you. You can use either of the one. Okay, so firstly you have to take the input, you have to take three numbers as an input, then you have to find out this greatest number. See, A, B, C, three numbers we are having. Firstly find out the greatest number amongst two, so store the result in D, then afterwards amongst your C and D store the result in E. Now at the last your E will be holding the maximum value for the same. Now moving forward with your second program, that is write a program in Java to calculate the diagonal of a cuboid taking length, breadth and height as an input. What you have to do? You have to take length, breadth and height. Only three inputs you have to take. Again over here also you can use any of the function to take the input, either scanner class or input stream reader, it depends on you. Then afterwards you have to convert this function, this expression diagonal equals to under root L square plus B square plus H square. You have to convert this mathematical expression into an appropriate Java expression using math.sqrt, and then you have to apply the formula for the same and you will be getting the answer directly. Okay, now see the third program. Write a program to input three angles 30, 45, 60 in degrees. You have to input three angles in degrees and calculate and display the value of sine 30, cos 60 and tan 45. Remember when we were learning your trigonometric function, over there we have studied that as an argument, if you are going to give an argument, then you have to give it in what? In radian you have to apply. Yes, so firstly you are going to convert these inputs into your radian using this formula. Yes, then afterwards you are going to apply the appropriate trigonometric function for the same. Okay, so try these questions. Now see the another question, fourth one. Write a program to input a number and evaluate the result based on the number entered by the user. Yes, you have to input a single number. Remember, only a single number you have to input, and based on the user's number that the user have entered, then you have to calculate all these things. So in the first one you have to calculate the natural logarithmic, it means you will be calculating in math.log. In the second one, absolute value, then you will be calculating what? Math.abs. In the third one you are going to calculate the square root, so again math.square root you will be using. In the fourth one, cube of a number. Now please remember, over here we have to calculate cube, not the cube root. So you are not going to use this CBRT function over here. You just write down a into a into a, or you can use this power function, math.pow, a as a base and 3 as a power, and afterwards this semicolon. You can use either of the two methods. And for the last one, random number between 0 and 1, again we are having one function for the same, that is your math.random. So please do these questions. The last sample program that is present in your book is the distance between 2 points A and B of a straight line whose coordinates are these and these. So you have been given a function and you have to write a program to calculate the distance between 2 points by taking the coordinates as an input. So see over here, these coordinates you have to take as an input. So x1, y1, x2 as well as your y2. So you are having basically four variables. Yes, so four inputs you have to take. Either you use a scanner class or you use input stream reader, depends on you. And then afterwards, firstly convert this expression into your Java expression again by using your math.square root. Then you just have to apply the formula and you will be getting the answer for the same. Yes. Now let us move forward to your exercise portion. See, the first question is what state whether the following statements are either true or false. Now see the first one. The return data type of math.log is double. It is clearly true. We have already learned regarding this. Yes. The second one, java.math class is used for different mathematical functions. Yes, true. We have learned different mathematical functions. The third one, the output of math.apps minus 99.99 is what 100.00. It is false. Why? Because when we were learning about math.apps, if you remember, then we have seen that only the signs are going to change. Yes, if you are having the negative sign, then it will be converted to your positive, and if you are having the positive, then there will be a no change. Yes, so this answer is basically false. Okay, now see the fourth one. Math.square root minus 225 cannot be defined. Yes, if you are going to calculate the square root of any negative number, then it will not be defined. It is true. See the fifth one. The output of math.cbrt minus 3 will be minus 27. CBRT function is going to calculate what? It is going to calculate your cube root. So if you are going to calculate the cube root of minus 3, then clearly it will not be giving you minus 27. So this fifth one is basically your false. Now see the sixth one. Math.round returns the value in float data type. It will be returning you the value in double data type. So it is also false. Now again see predict the output. Second part we are having. Second part, that is your predict the output. Now see the first one over here. You have to find out what math.floor value of minus 4.7. Yes, firstly over here see you are having a negative number and you are having what? Minus 4.7. If you round off this number, then you will be getting what? You will be getting minus 5.0, and minus 5.0 is smaller than your minus 4.7, and hence it can be used as your floor value. So the answer is minus 5.0 for this question. Okay, now see the second one. You have to find out what the addition of two function is there, math.rent as well as your math.square root. Now firstly see math.rent, you are having what? Minus 9.4. Then if you calculate math.rent function over this number, then it is going to give you what? Minus 9.0. Clearly because this is less than your 0.5 over there. Yes, and the double data type you are going to get, and that is why your answer is what? Minus 9.0. And for the second one, if you calculate math.square root 9.0, clearly you will be getting 3.0. So if you calculate minus 9 plus 3, then you will be getting what? Minus 6.0. So this is the answer for your second question. Now let us find out the output for your third question. We are having a nested function basically over here. Firstly you have to find out the CEL value, then afterwards you have to calculate the maximum value amongst these two. So if you calculate the CEL value for 15.55, remember your CEL value is going to give you your upper number, so it will be giving you 15.0 as an answer. So amongst your 15.0 and your 15.5, as it is written over here, you have to find out the maximum value, and clearly the maximum is what? 15.5. Hence for the third one your answer is 15.5. Now see the fourth one. Again, this is basically your nested function. Firstly, you have to calculate math.min among these two values, and then afterwards you have to calculate what the square root. So amongst your 42.5 and your 42.25, 42.5 is the smallest one. Yes, so you will be getting what? Math dot square root, in bracket you will be getting 42.5. Now calculate the square root of 42.5. You will be getting 6.5 as an answer. So for the fourth one, your answer is what? 6.5. You please try to do these questions on your own firstly. Okay, and you can let me know always in the comment if you face any problem with the same. Now see the fifth one. Fifth one is basically the addition function. You have to calculate the CEL value of 3.4 firstly. So let us calculate the CEL value. It is going to give you the upper higher value for the CEL one. Yes, so it is going to give you 4.0, the nearest higher integer. And then for the math.power 2 to the power 3, clearly it is going to give you what? 8.0. Now again you have to perform the addition operation. So 8 plus 4 will be going to give you 12.0. And hence 12.0 is the answer for your fifth one. Now let us see the third part. See, over here in the third section, you have to write down the syntax for the following function. So the first one is what? Let us zoom it out. The first function says to find the natural log of q. We are having already a mathematical function through which we are calculating your natural logarithmic. So you will be writing what? Math dot log, and in bracket you are going to give your this q value. And see, this math.log is going to give you a double number, so you will be getting what? Double v. Double v equals to math.log q, and afterwards your semicolon. This is the answer for your first one. Now see the second one. To find out the cube root of a number m, you are having a number m and you have to find out the cube root. So you will be writing the formula math dot cbrt, and in bracket write down m. Afterwards you will be writing what? A semicolon, and the value is going to be stored in a double variable, double v2 you can write down. Okay, so this is the answer for your second one. Now see the third one. You have to find out the round off value of a number k. The round off value, how we are going to calculate it? You have to write down math dot round, and in bracket you will be writing what? K, and afterwards semicolon, and the value will be stored in an integer variable. Okay, now write down int v3 for the same. This is the answer for your third one. Now for the fourth one, you have to find out the absolute value of a number. Over here write down the number y. It is misprinted over here, number y. So then you will be writing what? Math dot abs, and in bracket write down y, and afterwards this semicolon. The number will be stored in the data type. So over here see, math.apps is going to give you the value, and the return data type depends on this argument. So over here at the very first you define int y. That should be better. So then we can know that your return data type will be integer. So write down int y at the first position, and then afterwards you write down this value. Okay, so this is the answer for your fourth one. Now for the fifth one, you have to find out the exponent of a number p. Every time your exponent is giving you a double data type, double number it is going to give you. So double v5 equals to your math dot exp, and in bracket write down p, and afterwards just simply apply this semicolon. Okay, so these were the answers for your third part. Now for the fourth part, now see the fourth part, you have to explain the following function. Yes, math.random, math.pow, math.cbrt, and math.log. In your book only you are having the definition for the same. So please write down the definition followed by one example. Yes, and you have to write down all these answers and the previous one also in your copy. Okay, please mention the definition as well as one example for every function in your copy, as well as when you were asked to write down in the exam, then again you will be giving one example for every function. Okay, now for the rest of the exercise portion, in the next video we are going to discuss it. Now for now, some sample unsolved question you are having, so you have to note down these questions in your copy and you have to write down the answer for the same, and let me know in case you feel any difficulty for the same. And for the answers regarding these sample questions, in the next video I will be giving you the answer, but it would be good for you if you try these questions on your own. Okay, firstly try these questions on your own, then afterwards you can check the answers with mine, and if in case you find any difficulty, then you can let me know. So see the first question, you have to write down two separate programs to accept three numbers and find out which one is greater. Okay, use one using if statement and another using ternary operator. Okay, in the previous one, in the sample question, we have discussed what you have to use your MathMax function, but over here you don't have to use that MathMax function. Basically this question is from your third unit, so you have to write down two separate programs. The first program to accept three numbers, yes, and find out the greater one using if statement, and the another program to accept three numbers and find out the maximum using your ternary operator. So two programs you have to write down for this question. Now see the second one, which among the following are invalid class name in Java? Yes, you have to find out which are the invalid class name. Yes, you have basically over here you have to follow the rules of your identifiers. Okay, rules of identifiers you have to mention over here, and please mention state with reason. Please add on the reason over here. The first one compound interest, second one this, third one this, the fourth one is misprinted, so better to write down my class followed by this hashtag. Okay, the fourth one is this one. Now fifth one is also clearly visible. Now see the next question. What is the resultant data type of the following mathematical expression? See, basically you are having this mathematical expression. Now you have to find out what kind of data type you are going to get in return. And over here you have to see what you have to see, basically your hierarchy of your data types that we have studied in your third unit. Okay, so different cases over here we are having. The first one, when a is an integer, b integer, c float, and d is float data type. We have learned over there that the data type that is having the highest hierarchy will be acting as your resultant data type. So over here the values will be same, so please try to do this question on your own. Now again some more sample questions you are having. Okay, half of the portion is not visible. For now you just find out the output for this one as well as for this one. You leave this b and c part. For now just find out the output for this a part as well as your c part. So in the next video I will be giving you the answers, but please try to do the answers on your own, and then afterwards you can only check your answers. Okay, and you can let me know in case you feel any difficulty with the same. So these are all for this video. In the next video again we are going to discuss unit number 6, that is your mathematical library methods, and we are going to complete your exercise portion for the same. Thank you so much.